Hello everyone. In this video, we will introduce a core feature of GoInsight.ai, InsightFlow. It helps enterprises digitize and automate their business processes and combines AI capabilities to build various AI applications. There are three key concepts in InsightFlow: workflow, node, and variable. I will introduce these concepts one by one, guiding you through the basic architecture and core value of a workflow. First is the workflow. It acts as a digital SOP, allowing enterprises to replicate business processes and requirements within a workflow by combining them with AI capabilities. GoInsight.ai supports two types of workflows: interactive flow and service flow. Interactive flow is a human-machine collaboration workflow with a conversational interface. It supports multi-turn Q&A and intelligent collaboration, making it suitable for front-end scenarios requiring real-time interaction, such as customer service and consulting. It allows for automatic progression, human intervention, and flexible switching. On the other hand, service flow is an automated process without a conversational interface. It executes back-end tasks via API or triggers, suitable for unattended standardized operations like scheduled jobs and service calls, such as data cleaning and regular inspections. These two types of workflows echo the three cores of GoInsight.ai that we mentioned previously. For instance, when building system linkages and automated processes, interactive flow can automatically trigger automated processes through dialogue, while service flow can trigger automated processes via triggers or APIs. You can also use interactive flow to build AI applications, such as quickly setting up knowledge Q&A, customer service assistance, and AI processing, and publish them to employee portals or external channels with one click, truly integrating AI into daily enterprise operations. During the process of building AI applications, you can also use service flow to implement the reuse of certain repetitive logic. Let's take interactive flow as an example and create a new workflow. The page you are seeing now is the workflow editor. At the top is the workflow menu bar. Here you can find some common workflow functions, such as template. Here we have prepared some templates that we think are quite good for you. You can copy its prompt directly to an LLM node or agent node, or use that prompt as the standard to directly generate an agent node or LLM node. There are also features like workflow save and publish, basic settings, workflow debug, workflow download, and so on. In the middle is our workflow canvas. Here you can build and edit the workflow. At the bottom is the workflow toolbar. Here you can zoom in and out of the workflow canvas, view the change history of the workflow, and insert nodes, notes, etc. A complete workflow generally consists of multiple nodes. A node acts as an independent operation unit, representing a specific task, event, or decision point. Each node is responsible for executing a specific function or step, and determines the subsequent path of the workflow based on its configuration and input conditions. Nodes are connected to each other via connecting lines to form a complete process structure, allowing data and operations to flow smoothly within the workflow. GoInsight.ai provides a very rich set of nodes. You can select different nodes according to your needs to build your business process. Regarding the specific use of each node, we will introduce them in detail in future videos. In addition to basic nodes, we also provide very rich tools and apps to help you quickly build workflows. We will also introduce tools and apps in detail in subsequent videos. After you have added different nodes to the workflow, how is data passed between different nodes? This brings us to our third key concept: variable. The role of a variable is straightforward. It stores and passes data within the workflow, allowing different nodes to share information. For example, I have an LLM node here. Its output variable is text. In the subsequent answer node, the text variable is output as the reply. This achieves data storage and transmission. In the node configuration, you can also insert variables using the / key. In the start node of an interactive flow, you can see many system variables There is the query variable representing the user's question, and date and time variables representing time. These variables can be used later during the workflow building process, playing a very critical role. Having covered the basic concepts, let's look at 4 practical cases to intuitively see how workflows are built and what effects they can achieve. For the first case, let's use a workflow to replicate the effect of the QuickBot we introduced in a previous video. In the QuickBot video, we provided context support for the AI through a knowledge base, enabling the AI to master the enterprise's internal data and knowledge. In a workflow, we can similarly provide context support for the AI. This is where we can use our knowledge base retrieval node. This node also leverages RAG technology to retrieve appropriate knowledge base fragments from the corresponding knowledge base based on the input content. Here, I will take the user's question, which is the query, as the input parameter for this node. Then let's select the corresponding knowledge base. Here I will use the sample knowledge base as an example. Select Save. In this node, we also have top K and relevance threshold settings. These were also introduced in our previous QuickBot video. You can adjust these 2 configuration items according to your needs. I will stick with the defaults here. So this node is now configured. Next, let's look at the LLM node. You can select different models here according to your needs. We provide a very rich and diverse set of models. In this case, we are using the Azure GPT 4.1 mini model. The system section here represents the instructions you want to give the AI. In this case, we hope to simulate the effect of QuickBot, so the instruction I give it is. Of course, we also know that the prompt is crucial for the LLM node. Therefore, you can also use our AI writing to enrich the prompt. Afterward, you can click to apply the prompt. Of course, you can also review the prompt to see if any changes are needed. The user section represents the instructions provided to the model, questions, or any text output. We generally place the user's question in user. In this case, we place the knowledge base retrieval results in user. You can also turn on the memory function of the LLM node so that the LLM can access the context history of multi-turn dialogues. Here, you'll find the file system variable. When working with multimodal LLMs, you can use this system variable to pass in images or documents, enabling the model to process and generate outputs based on the file content. Now our LLM node is also configured. After that, we just need to use the answer node to output our LLM node's output variable text. Once you have initially built the workflow, you can debug it using Debug Preview. Let's look at the specific operation of the workflow in this case. Here we first input a sample question. You can see the AI gave us a very good answer. Let's see how the workflow actually operates. First, let's look at the start node. You can see that in this case, our question has been passed as the query variable into the entire workflow. Then, in the knowledge base retrieval node, we took the query variable, which is our question, as the input variable to perform a knowledge base retrieval. You can see that this node gave us 3 knowledge base fragments related to the question. Then you can see that we gave the question and the results of our knowledge base retrieval to the LLM. Subsequently, our LLM node provided a very good reply based on the information we provided. This reply is an answer based on the results from the knowledge base. In this process, you can clearly see how variables are passed between different nodes. This is the first case we demonstrated. It replicates the effect of QuickBot, allowing AI to answer based on the content of the knowledge base. Next, let's look at the second case. We remove the knowledge base retrieval node and let the LLM directly answer a question. Of course, here I need to delete some irrelevant variables and settings from our first case. I also modified the prompt here to fit the prompt needed for this case. Let's look at the answer effect in this case. We will use the same question as in the first case. You can see that compared to our first case, the AI answer in this case is not based on our knowledge base. Because we did not add any knowledge base retrieval-related nodes in the workflow, the AI actually has no way to master the knowledge inside the knowledge base. The answer it provides is based on the knowledge the AI has currently learned. The effect of such an answer may not be as good as the effect in our first case. Okay, that is the demonstration of our second case. Through these two cases, you can clearly see the ability of the knowledge base retrieval node to provide context support to the LLM node within the entire workflow. Next, let's look at the third case. Let's see how to use a workflow to enable AI to perform web searches. Here, let me introduce a very useful node to you, which is the agent node. Although both the agent node and LLM node can combine AI to generate content, they are different in positioning and capabilities. The LLM node is more like an intelligent writer. Its core capability is to generate corresponding replies based on input information. However, it will not act proactively, nor can it call external tools. For example, in our previous case, the pure LLM node could only rely on its own memory and trained knowledge to answer. It had no way to search the web for the latest information or crawl web content on its own. The agent node is more like an AI executor with autonomous capabilities. It not only possesses the basic ability of AI to understand and generate content, but more centrally, it adds the key capabilities of autonomous decision-making and tool calling. It can proactively understand complex task requirements, determine which tools need to be used, and automatically call tools to complete operations, all without manual intervention. After we add an agent node, you can select its agent strategy. It has two built-in system strategies. One is the React Compact Executor. It is a streamlined strategy optimized for structured tool execution, using a minimalist prompt template to ensure efficient API calls and concise JSON format output. It is very suitable for task automation and back-end integration. The other one is the React Enhanced Orator. It uses a richer prompt template, supporting dynamic response formatting, context supplementation, and multi-turn dialogue logic. You can choose the appropriate agent strategy according to your needs. If the built-in agent strategies cannot meet your needs, you can also create custom agent strategies later. The model settings here are the same as the previous LLM node. You can choose the appropriate model according to your needs. In this case, we also select Azure GPT 4.1 Mini. Then let's add tools that the agent node can use. Since I wanted to perform web searches, I added Google Search from our built-in tools here, allowing the agent to search the internet. Next, in the instruction section, let's input the instructions for the agent node. Finally, we insert the system variable query, representing the user's question here. You can also set the maximum iteration count for the agent. This represents the maximum number of times the agent thinks and acts. For simple tasks, we generally recommend 5. If it is a complex task, you can adjust it according to your needs. The agent node also has a memory function. In this case, we also turn on the memory function. The agent node also supports passing in images or documents via the file's system variable, enabling the model to process and generate outputs based on the file content. Now the workflow is basically configured. Next, let's test the running status of this workflow. For example, I ask it to search for today's weather in New York. You can see the agent node performed a real-time web search. Let's try another question. You can see the agent node thought in the same way, then called the Google search tool, and finally returned today's gold price to us. When you are sure the workflow construction is complete and meets your expected logic, you can click to publish the workflow. After that, you can publish the conversational workflow as a chatbot. This is the same as the sharing method we introduced with QuickBot. You can share the workflow via URL, iframe code, chat widget code, etc. Workflow permissions and security are also very important. You can set the security settings for the workflow, as well as the permission scope for the workflow. That concludes the demonstration of Case 3. To summarize, the agent node is a very convenient and powerful node. You can assign it different tools and issue different types of tasks. The agent node will automatically break down tasks for you and call the corresponding tools. Configuring the agent node is very simple. For most users, we highly recommend using this node to build workflows. In future videos, we will have more cases to demonstrate the power of the agent node. Next, let's look at the fourth case. The first 3 cases were all built based on InsightFlow. You will notice that essentially, they still require dialogue to trigger the workflow to run. However, in actual business processes, there are many businesses that require no human intervention and need to run on a schedule. This brings us to our other workflow type, service flow. It is designed specifically for unattended standardized operations like scheduled jobs and service calls. For example, I have built a simple service flow here. We called a built-in connected app in GoInsight.ai, Slack, to let it help me send a message to Slack. We can run it to see if it achieves the desired effect. You can see it ran successfully. Let's go to the Slack page. You can also see that it successfully sent a message to the corresponding group, indicating that our workflow configuration is correct. Regarding the introduction and configuration of tools and apps, we'll be covering those details in our upcoming videos. Of course, to achieve daily automatic execution of this workflow, once you ensure the workflow meets your goals and logic requirements, you can click Publish. Afterward, let's use the trigger for service flow. Here you can customize the scheduled running time of the workflow, frequency, and other settings according to your needs. For service flow, you can also trigger the workflow via other methods. For example, the common API. You can trigger the service flow to run via API. You can also choose whether to close enabled access tokens. Of course, you can also publish our service flow as a service. For example, here I publish it as test service. Let's click Publish. Afterward, you can see that in other workflows, you can find the service we just published. You can directly call this service to run within other workflows. Alright, that roughly covers the introduction for this video. Thanks for watching. See you next time.